Okay, another boat problem brought to you by Math Excel. Two ships leave harbor at the same time, so we need to know where our harbor is. So let's put our harbor right here. This is the point that they're leaving from. One ship travels on a bearing of south 11 degrees west. So here's another one of these nautical bearings. So what I'm going to do is I'm going to create a north-south line that passes through that because they're leaving from this space, okay, and they are traveling. Let's use this. They're traveling from south to the west only 11 degrees. So from south, west is in this direction from south. So due south, 11 degrees to the west. So not much, right? And it travels at 16 miles per hour, and this happens for 3 hours. So what I've drawn here would indicate, because I have no other context to this problem, this is the entire path of that boat. And let's label it right now. If this happens for 3 hours at 16 miles per hour, then this is going to be 48 miles long. And we know that this is 11 degrees. Okay. We have a second boat that is traveling on the direction of north to the east, 75 degrees at 9 miles per hour. So not traveling as fast, not going to go as far, right? And traveling at 75 miles per hour. So we'll put that right about there, I think. So we have a distance of 27 miles for this, right? And this is 75 degrees. So maybe I should move this out. In fact, why don't I do this to make this problem a little bit easier to look at? Let's make this a little bit longer, and let's make this a little bit longer, just because. Let's move this 27 up here, okay? And that way I can label this angle properly. So this angle is 75 degrees in this direction, right? From north to the east, 75 degrees. Question is, how far apart will the ships be after 3 hours? So they want to know, here's one ship right here, here's the other ship right there, and they want to know, what is this distance, right? What is this? If we wanted to accurately label this with a variable, you know what I'm going to call this? What do you think? Any guesses? I'm going to call this P. Why am I calling it P? Because this is the port, right? This can be ship B, and this can be ship A. That was the first one that we labeled. Now, when you look at this information, we have a triangle here. We have this north-south line, but we also have a triangle where we know some of this stuff, right? We know this side length, and it's important that when you draw your schematic or your what this problem, way this problem set up, that you label the parts of the triangle that you know. I know that this side length is 48, and I know that this side length is 27, okay? But I don't know anything else about that. I certainly don't know this angle, okay? I don't know this angle. Now, this angle, this is clearly where the crux is going to take place. The majority of the information in this problem. I need this piece, right? And there's a couple of different ways to go about finding that angle. If I know that angle, then I know this side, and I know this side, and I know the angle that is formed between them. That would be a side angle side relationship, which means I can use the law of cosines. Okay, so what we have here, every north-south line is a vertical line, right? So the measure of the angle that starts here and comes all the way over, that's 180. Well, I have this piece right here. This is 75, which means all the way over to here would be 180, right? Which means this piece and just this piece right here, be careful about how I shade this in, but this angle is 105 degrees, right? And then if I add this other 11 degrees, which is over here, then the triangle, and this is always going to be my suggestion to you, take it or leave it, this is 116 degrees, this is 27, this is 48. My advice is always going to be to label the triangle separately. Draw it separately without all of this nonsense going on and just label what you know about the triangle. Okay, this is the value we're trying to find. We know the angle that's opposite that side length. So we have side, angle, side. I'm going to use the law of cosines. Remember, the angle that we know is the angle, or the angle in question, the one angle that we have for this problem is going to go inside the cosine, and then the side across from whatever this angle is, that's what's going to be isolated on the other side of that formula. Okay, so we have the cosine of 116 degrees here. We have our other two sides, 48 squared plus 27 squared minus 2 times 48 times 27 times the cosine of 116. Okay. I don't think I'm going to take this problem all the way to the end. You would see here, there are no variables here, right? And we're never going to be able to do this in our head. So we can just calculate. You can type this into Desmos, into your TI Inspire, whatever you have as your calculating device. Type it in exactly how you see it, and then take the square root of that to get P. Okay.